Hello everyone, welcome to our discussion of section 1.1 in this college algebra course, otherwise known as Math 124. This is a wonderful class because it covers very basic but essential math skills for you to succeed in your own majors. I know many of you are not majoring in mathematics. You have your own wonderful majors that you like to pursue, and this course helps you gain some of the essential mathematical skills you need to succeed in your major field and in your major field courses. I've looked at this course material. Some of the people that I know who practice professionally in various fields, accounting, nursing, they tell me that they do use many of the mathematical skills they learned in college algebra. So these are, again, basic math skills, but they are very essential in many professions. Okay, over the years that I've taught this subject, I've noticed that my students' critical point is that the critical thing about many people kind of being afraid of this subject is that they don't know how to study it. They are fully capable of excelling in this course and other math courses. It's just that they don't know how to study this subject. So I've put together, not Math 126, but I've put together this list that is useful. These are the steps to study this and any quantitative course, whether you're taking marketing, accounting, finance, economics, any of those quantitative courses that you have ahead of you. The way to study them, it's kind of different than when you study other subjects that are not so quantitative. This is a short list, and you should do this before attending any class, any lecture in person on campus, or watching this video. So the first thing you want to do is you want to skim through the textbook section and topic before it is covered in class. So you might hesitate to do that because you might think, well, how would I read the section before even it's covered in class? I won't get much of it. That's what you think, but in fact, that's not true. The way it works is when you read a text, whether it's this math book or another course that you might be taking, your mind starts in the background to work on this stuff that you read. It starts without you even knowing it. Your mind starts to make sense of things you read in these texts, and mathematics being one of them. So as your mind does that, then when you watch this video and when you attend class in person on campus, then you absorb at least 95% of what is being discussed in class. That's because your mind has already, without you even knowing it, started to make sense of the things you've read. But the prerequisite for that to happen is that you read the section. And I'm not talking about spending 2, 3, 4 hours on the section. I'm talking about the first read. The first read of the section, which should happen before you watch this video or attend the class in person. That first read should not, under any circumstance, take you more than an hour. So you're browsing through the section, not taking it lightly, but you are trying to just read through it, get a feel for what is being discussed, the kinds of things that are being discussed. And it should normally take you about half an hour to 45 minutes. That's what I'm talking about. Half an hour to 45 minutes reading through this section before you watch the video or attend the class in person. It makes wonders in understanding this subject. And second thing is that you watch the video or you attend the class regularly, minimizing your absences, and then taking notes in the process. So for example, if you read the book and something catches your attention as a question mark, something that you're puzzled about, you should write that down in your notebook, a question mark. And the other thing is that you might read and something might strike you as very important. You should also write that down in your notebook. And then when you review this stuff, you simply go back to these points that you've taken notes on. And then, of course, the questions you're going to ask me, or in class, you're going to be particularly attentive to make sure that you get answers to your questions. And for later, as I said, for later review of the material, these notes are also very, very important. As you read so number 3, as you read the textbook, as you watch the videos that I am preparing now, you're going to see many, many examples that I go through, and many, many examples that your textbook author has gone through. So you want to solve all these examples on your own without looking at the solutions we give. So in the textbook, for example, you want to cover that with a blank sheet. Just simply cover the solution, read the problem, and answer it, and then look at the solution in the book. You can do that very easily. With videos, you can do that even more easily. You can simply pause the video, right? You can simply pause the video and then unpause it when you're done with your solution to see if your solution agrees with my solutions. And that is the way to study any quantitative subject. So after doing this, then complete all homework assignments by the due date. You do not want to put off completing these because cramming will not help. It's very, very counterproductive. And all of this, the semester is for about 4 months long, just about. And there is a reason for that. So you want to distribute the material that you want to study over that time frame. Preferably even be ahead of me rather than be behind and trying to catch up with me. Okay, it's preferred that you work and study ahead of the class, each class that you're taking. And finally, of course, review. You want to review throughout the semester because each of their regular exams will cover just chunks of chapters, and then the final exam is going to be cumulative. And of course, any other course that you take for which this course is a prerequisite, then it'll require you to use these skills in that class as well. And as I've said, this math subject is basic, but it's ubiquitous. It's everywhere. It's in academia. It's when you become professionals. You will use this level of mathematics in your work space. So hopefully this material will stay with you and you won't forget these that easily. Okay, so just like I say, I've been doing this for now approaching, at the time of when I'm recording this video, I've now been teaching mathematics for 19 years. That includes the time when I was a graduate student and then later when I transitioned to full-time faculty. So I know the number one obstacle for my students is that a lot of them don't know how to study it. But now you know. So these 5 steps are key to doing well, not just in this class, but also in other quantitative classes. Okay. All right, so having said that, let's begin with the start of this topic, section 1.1. So a lot of this you've seen before, which is fine. So all math classes overlap at the beginning, and then after maybe 20, 30 pages, then you start seeing newer or more new material. Okay, so I'm counting on the fact that you've You've seen this material before about the Cartesian coordinate system. So the Cartesian coordinate system, which otherwise known as the XY plane, and you see a graph of it here, is broken up into 4 major quadrants. And we label these quadrants in a counterclockwise direction. So first quadrant, second quadrant, third quadrant, and fourth quadrant. Those of you who will be taking trigonometry, if that course is part of your study program, which is Math 127, you will be using this throughout the semester. And the fact that where are the trigonometric functions located? Are they in the first quadrant, second, third, fourth quadrant? You will be concerned about that for the entire semester. Very, very important. Okay, so as we know, in the first quadrant, all of these numbers on the right are positive and alongside the y-axis. And on this side to the left of the origin, which is 0, we have negative quantities. And vertically also we have negative quantities. Okay. So any point located in this XY coordinate system within this plane has an address. And the address of it is called the ordered pair, which is shown by that. This is how we show ordered pair. Of course, that's when we talk about ordered pairs. But if you're talking about intervals, then that notation refers to the interval of some sort. But in this case, it's called the ordered pair, and it's the address of any point that is located within this XY coordinate system. And also this XY coordinate system is also called the Cartesian coordinate system. That's a more formal or mathematical name for it. Okay, so this is an example for us to go over. Consider these points that are shown, and we want to give the address for each of these based on the axis that we have. I think this would be a very good point where you should pause the video, write down your own solution or coordinates for each of the points on a piece of scratch paper, and then unpause the video and then look at what I write down. If you watch these videos and write down your own solution before you see my solutions in the video, you will progress very, very fast, and you will excel this course. Okay, so that's another trick to study this subject. You don't want me or anybody else solve these problems as you sit there and watch this. You should actively get involved and solve problems before you see the solutions. Okay, so this one, I'm assuming you've done that, and now you have the solutions in front of you. So the coordinates for this point would be, the x component would be -2 right there, and the y component is 1, positive 1, right? The coordinates for that point, the x component is 2, comma, the y component is positive 2, right? The q, we have 4, x equals 4, comma, y equals 1. Okay, the point P, the x component is -2, the y component is also -2, right? -2 along the x-axis, -2 along the y-axis. Coordinates of this point, what do you think? Its x component is 2, and the y component is -2. Okay, I hope these these coordinates agree with what you have on your own paper. Okay, so this equation, 3x plus 5y equals 12, as an example, it represents a straight line. Okay, it represents a straight line. So this is because the reason why we know that this is representing a straight line, not a curvilinear graph or line, not a curve, is that because the power of the variable x and y, actually, these are 1. right? X has power 1, y has power 1. And also the variable x is not part of a fraction or a root function. So if we had, let me use a scratch paper to write this down. So for example, that is not a straight line. In fact, if you graph that, it's gonna do something like that. So it's not a straight line. Okay. Also things like that. If you have y equals x squared, that's also not a straight line. The graph for that is something like that. Okay. But here, none of that is happening. You don't have a square root. You do not have squared x squared or y squared or anything of that nature. So it is a straight line. So if you have any kind of line, and this extends to lines that are not straight, they are curves, just like the ones that I've shown you. If a point is on that line, if you have a straight line, I'm just using this as a scratch paper. So if you have a straight line like this, and suppose we put the x and y here, and suppose any point on this line must satisfy the equation of this line. Any point on this line must satisfy this equation. So if you put that point inside here for x value and for whatever the x value, if you input that x point here, the y value you get must equal the y value you have for that point. Okay, so the same way for this. Any point on this line should satisfy this equation. That means the x and y for that point should satisfy this equation. So if you plug in the x quantity or x coordinate for that point into this equation and square it, you should get the y value for it. Okay, so any point on a line should satisfy this equation. So to follow that, we have these examples. We want to know, determine if the given ordered pairs, if these ordered pairs are the solution of the given equation. That means if they're on this line. If that's the case, then when we plug in these coordinates into this equation or these coordinates into this equation, we should get both sides equaling each other, which means these points are on that line if these coordinates satisfy that. So before you see my solution, it would be a good idea to pause the video, run that check on your own, and then come back to the video. And I'm assuming you've done that. So let's test this point first, right? That one. So I'm going to plug for x with 1/2 and for y with 8. Okay? 8, right? I'm plugging this point in here. 8 for y equals, we're checking. We don't know. We're checking to see if that is equal to -4 times 1/2. I'm plugging for x with 1/2 plus 10. Let's see. 8 minus 4 times half or 1/2 is -2 plus 10. 8 equals 8. So the question mark we had about this equality being valid checks out. We now have an answer for that. So yes, this point is on that line. Okay, so let's check this point. Once again, we substitute for y with 6, and we substitute for x with -1. -4 times -1 plus 10. Right? So 6 minus 4 times -1, +4 plus 10. 6 equals 14. Is that a true statement? Is the left-hand side equal to the right? Absolutely not. right? So this is impossible. So this minus 1 comma 6 is not a solution of this given equation, and it's not on that line. So this is okay, but minus 1 comma 6 is not a solution of the equation, and therefore it is not on that line. Okay? Here we have 2 more points. So let's plug in and find out. First, we're going to plug or check that one. Substitute for x with 2, so we have 5 times 2 plus 2 times y squared. Y is minus 4 squared equals 70. And we're not saying that this is the case, but we're checking that. When we substitute these coordinates into this equation, is the left-hand side equals 70? That's what we're asking. So 10 plus 2 times minus 4 squared is positive 16, because minus is being raised to this power 2 distributes itself both to negative and the 4. So because minus is being raised to an even power, it's going to drop out. So it's going to become positive, right? Minus to a 4th power, 6th power, 8th power, any even power cancels it. So we have positive, and 4 squared is 16. And we want to know if the left side equals to the right, right? So we're asking that question here. Okay. So we have 10 plus 32 equals 70. We're asking if that's the case. The left side is 42 equals 70. Is that true? Is that true? No, right? No. So 2 comma negative 4 is not a solution. Is not a solution. And it is not on the line. See, that's not a straight line, right? Because of this y squared and all of that. So that's not a straight line. But the way we check if a point is on a line or not is the same. It doesn't change. So we plugged it in, and the 2 sides are not equal. So that point is not on this line. It's somewhere else. Okay? So let's test that point, that one. We're going to plug for x with 4, for y with negative 5, and we're asking if the left side is equal to the right. So 5 times 4, 20, plus 2 times minus 5 squared, that's positive 25, right? Minus, this minus squared is positive now. 5 squared is 25. Okay? We're asking if the left side equals 70. So 2 times 25 is 50. 70 equals 70. What do we have? We have a check. So it is 4 comma negative 5 is on this line. It is a solution of that equation. Okay. Okay, so graphing of an equation is something we will do this throughout this course. One way to graph an equation, that's one way, not the only way, but one way to graph an equation is to find a few easy points. Emphasis is easy points, right? On the line that the equation represents, and then connect the lines with a smooth line. we're not really doing anything different than, when we were kids and we had these books where there were dots on it and we had to connect all the dots to see what kind of animal or what kind of tree or house or automobile is there. Remember that? This is the same thing. But instead of the points having been given to us, we need to find those points. And once we find those points, then we'll connect them with a line. Sometimes that line is a straight line. Sometimes it's a curve. Sometimes it's something else. But that's the whole thing we're doing with graphing equations. Now, when the equation is linear, okay, when the equation is linear, that is when the equation represents a straight line, only in this case, the easiest way to graph the line is to find the x-intercept and the y-intercept. So the x-intercept, let me do a graph, a little graph right underneath this text. Suppose we have a line here that goes like this, right? Suppose that's a straight line, even it looks like a curve, but let's assume this is a straight line that has a negative slope, right? It's going downhill from left to right. And we always read the graphs from left to right. So that line, the straight line, intersects the y-axis and the x-axis at points, right? The point at which this line intersects the y-axis, it is called the y-intercept. And the point at which it intersects the x-axis, it's called the x-intercept. Okay? When we deal with graphing, when we're asked to graph a straight line, it's the easiest to find these 2 points. The easiest way is to find these 2 points and then connect them with a straight line. Why is it the easiest way? Well, the reason is because if you're on the intercepts, one of the components, either x or y, has to be 0. So for any x-intercept, the y component is always 0. Why? Because it's on the x-axis, so there is no movement along the y-axis. If you're on the x-axis, for any point that is on this x-axis, the y component is always 0, right? Because there is no up or down movement for any point on that axis. So for the x-intercept, as I've mentioned here, and let me highlight that, for the x-intercept, the y component is always 0. And then you're going to find what the x value is. In other words, where along the x-axis that intercept exists. That's the question mark that you'll have to find by plugging for y with 0 in an equation. And for y-intercept, the x value is always 0. So for that component, for this y, notice if you're on this axis, there is no movement along the x-axis, right? If you're on the y-axis, you haven't moved at all along the x-axis. So you always have the x component 0, and the y component is something you have to look for, which is very easily done. When you plug in for x or y with 0, that term drops out, right? That's why it's easy. So then it's easier to look for y, because one of the terms in the equation has dropped out. Okay? And I should complete this like that. Okay? So this isn't the case. The x and y intercepts are not they're still a good way to roughly guess or estimate where the curves go. But for any curve that is not a straight line, you're going to need more than x and y intercepts. Okay? For the straight line, this case, that's the only 2 points you need. And it makes graphing very easy. But for any other graph that is not a straight line, you're going to need more than just x and y intercepts, because the line is not straight. So you need more points to know what the line is doing. Is it going up? Is it below the x-axis? Is it above the x-axis? You know, at some points. But we'll look at those too later on. So here we have the following figure shows the x and y intercepts of a line. So the way I've designed these worksheets that we're going through, and the blank ones will be posted, and I guess you guys want me to post these solved solutions too, and that's not a problem. I would post the solutions as well as the blank ones, but please, you keep your side of the bargain and don't look at the solutions unless you have given yourself the opportunity to solve those problems with your own mind, with your own head. Give your head to work on these solutions before you see my solutions. And if we work together like that, then I think each and every one of you will succeed if we work together like that. So I'm doing this and you do that, and just don't look at the solutions and try to memorize my solutions. Work out the problems on your own and then look at my solutions. I think that would be a winning strategy for us all. Okay, so as you can see, and I drew the graph on the other page, the y-intercept is that, and it's going to have, any y-intercept, it's going to have its x component 0, and the y component is going to be some number. The x-intercept will have its x-intercept figured out, but the y component is going to be 0, right? Make sure you understand what's going on here about the components, the 0, x value 0 for the y-intercept, and y value 0 for the x-intercept. So here is an example. The x-intercept is -4, 0. Right? Notice that x-intercept has y value 0. And for the x-intercept, for the y-intercept, the x value is 0 and the y value is 6. Okay? Once you know those 2 points, you can just draw a line right through them. So in the next examples, in the next 2 examples, we're being asked to find the x and y intercepts of the following equations. Okay, so that's easy. For x-intercept, and please pause the video, answer both of these on your own, find the x and y intercepts, and then look at my solutions. I'm assuming that you've done that. So for the x-intercept, which component is 0? If you said the y value is 0, you're absolutely correct. And we're going to look for the x value, right? Okay, so let's plug in for y with 0. 2x minus 4 times 0 equals 8. 2x, that's 0, right? Equals 8. Whenever we're solving for a variable, what we're doing is we intend to isolate that variable. Right now, x is not isolated. It's got a 2 next to it. So we got to get rid of this 2. How do we do that? We divide both sides by 2. And we end up with x equals 4. So what is the x-intercept? The x-intercept is 4, 0. Now let's look at the y-intercept. Which component is 0 for y-intercept? The x component, right? If you said that, that is absolutely right. So in this equation, let's substitute for x with 0 and solve for y, which is that question mark. So 2 times 0 minus 4y equals 8. 0 minus 4y equals 8. We end up with minus 4y equals 8. And we're solving for y, right? So y, that means we need to isolate y. Is y isolated? No. It's got a negative 4 right next to it. We need to get rid of it. How do we get rid of it? We divide both sides by negative 4. So we have 8 over negative 4, or y equals negative 2, which means the y-intercept is 0, comma, negative 2. Okay, I hope this is making sense, guys. So this one, again, I'm hoping that you've already solved this on your own, on a scratch paper. And now you're here watching to see if my solution agrees with your solution. So once again, for the x-intercept, let me move this up a little bit. So for the x-intercept, which component should be 0? The y component, right? And the x component we're looking for. So we're going to, in this equation, we're going to substitute for y with 0. So 3 times 0 plus 2x equals minus 6. 3 times 0 is just 0, right? So we have 2x equals negative 6. We're solving for x, which means we need to isolate x. X is not isolated. It's got a 2 right next to it. So how do we get rid of this 2? We divide both sides by 2, right? Divide both sides by 2. We end up with x equals minus 3. So what is the x-intercept? The x-intercept is negative 3, comma, 0. So we figured out that that question mark is negative 3. The y-intercept, which component of the y-intercept is 0, x or y? If you said x, you're absolutely correct. Right? X is 0, we're going to look for the y. So let's, in this equation, let's substitute for x with 0 and solve for y. So we have 3y plus 2 times 0 equals minus 6. 2 times 0 is 0. 3y equals minus 6. We're solving for y, which means we're going to need to isolate y. Is y isolated? No. It's got a 3 next to it. How do we get rid of the 3? We divide both sides by 3. So we have y equals minus 2, which means the y-intercept is 0, comma, negative 2. Okay. All right. So here, we're asked to use the intercepts. We now know how to obtain the intercepts, right? We just did a couple of examples on that. So now we're asked to do that, to obtain the intercepts, use the intercepts, that's referring to x and y intercepts of each equation, to graph each line. So let's do that. We're going to find the x-intercept, then the y-intercept, then we're going to plot these each equation. Okay, so again, please pause the video. Answer on this page. There's A, B, and C below, which you're not seeing at the time. Solve all these because the blank ones are posted on Canvas, right? You can just look at those blank ones, blank worksheets, and on a piece of scratch paper, answer these and then come back to the video. Okay. So x-intercept, that means the y value is 0 and the x value we're going to look for. So plug for y with 0, solve for x. So 0 equals minus 2x minus 1. Let me move the negative 2x to one side because we're solving for x, right? Which means we're going to have to isolate x in order to solve it. So the first thing you would do is separate this negative 2x from this negative 1. You can either move negative 1 to this side or negative 2x. It makes no difference. So move the negative 2x, or I'm going to move negative 2x to the left. On the right, it was negative, right? It had a negative coefficient. When I move it across the equality, it's going to be positive. Positive 2x equals minus 1. We have one more step to isolate x or solve for it, right? So there's a 2 next to it. We need to get rid of this 2. How? Divide both sides by 2. We get x equals minus 1/2. Okay, so the x-intercept is negative 1/2, 0. Okay, let's see. All right, so the y-intercept, which component of the y-intercept should be 0, x or y? If you said x, you're absolutely correct. And then we're going to look for y. Okay, so let's substitute in this equation for x with 0 and solve for y. So y equals minus 2 times 0 minus 1. Y minus 2 times 0, 0 drops out. Y equals negative 1. So the y-intercept is 0, negative 1. Okay. All right, so let's plot these 2 points and graph this line. Negative 1/2, 0, that means this is 0, negative 1. So negative 1/2, 0 is halfway between 0 and negative 1. Right there. And then 0, negative 1, that's on the y-axis, that's right there. Okay. So now we can connect those 2 points with a straight line. Like that. If you like, I can label these. That point is negative 1/2, 0. That point is 0, negative 1. The x and the y intercepts. So does this line make sense? I mean, does it make sense given this equation? Does it make sense? The answer is yes. Why? Because look at the equation we have is in which form? It's in slope-intercept form, right? Y equals mx plus b. Remember that? This equation is in this form. You can write a straight equation or a linear equation in 3 different ways. This is one of those ways. This is a good way of writing the equation if you're interested in knowing what the slope of the equation is right away. Right? If your equation is written in y equals mx plus b or in slope-intercept format. Oops, let me bring this down. I was just going to lay, so this is the slope-intercept. It's called a slope-intercept form. That one. Then the slope is clearly shown. It's the coefficient of the x variable, right? That number, whatever it is, it's the slope of this whole line, the slope of the whole straight line. So in our case, that's negative 2. Because it's a negative number, it means that the line must be downhill, sloping downhill from left to right. So take a look at this line from left to right. Not from right to left. Right to left, it will be increasing, which is not the correct way of reading a graph. Read the graph from left to right, and it's declining, right? It's going down this way, which means it has a negative slope. It has a negative slope. So, which is clearly shown what that slope is, right? It's a negative 2. So this line makes sense given this equation. All right, so part B. I'm hoping that you've done this on your own on a piece of scratch paper, and now you're checking it with my solution. So once again, let's use the x and y intercepts to find the graph of this line. X-intercept means that the y value is 0, and we need to look for the x value. So let's plug in. We have 0 equals 2 minus 4/3 x, right? I just plugged in for y with 0. We're solving for x, which means we're isolating it. So let's put this whole term with the x term in it, with the x term on the left side, just to isolate it a little more. 4/3 x equals 2. Now we moved it to the other side as 2. So x is now a little more isolated because we're solving for it. Now let's multiply both sides by 3. We can do that, right? So 3 times, this is just to clear the fraction. 3 times 4x over 3 on the left, and 3 times 2 on the right. So the 3 and the 3 cancel out. We end up with 4x equals 6. Right? I'm running out of space, so I'll put the y-intercept here, so it's okay. So we're isolating x, so how do we do that? Divide both sides by 4. 6 over 4. Can we simplify this? Absolutely. We have 3 over 2, because 2 is a common factor of 6 and 4, right? When you take the common factor out, you end up with 3 over 2. So the x-intercept is 3/2 comma 0. Okay. What about the y-intercept? Let me put a dividing line here so things don't get mixed up. So the y-intercept, which component is going to be 0 for a y-intercept? If you said x, wonderful. So let's replace in this equation with 0 for x, and then we're going to solve for y. Minus 4/3 times 0, right? For x with 0. So that term reduces to 0. We have y equals 2. So the y-intercept is 0 comma 2. Right? We have the x-intercept and the y-intercept. Can we plot this? Absolutely. Let's do it. 0 comma 2 would be here, right? 0 comma 2. 3/2, that's just 1.5 comma 0 would be between 1 and 2 on this side. And then we can connect those two lines with a straight line, like that. Okay. Does this line make sense given that equation? Yes, because this is once again moving from left to right. It's a declining line. It has a negative slope. And look at we have slope-intercept form again, right? Y equals something. The slope of that x, the slope of this equation written in a slope-intercept form is negative. So it's going down. So the slope of that line is negative, and it's equal to minus 4/3 right there. Okay, so it makes sense. If you like, we can label those intercepts as well. So the y-intercept is 0 comma 2, and the x-intercept is 3/2 comma 0. Okay. Part C. Please make sure that you've done this before you see my solution. Okay. All right. So the x-intercept, this is an interesting case because, as you see in a minute, the x and y-intercept are the same thing. So for the x-intercept, the y component is 0 and the x is a question mark. So if we substitute for y with 0, So we have this equation, right? X squared equals 0, which means x equals 0. So what about the y-intercept? For the y-intercept, which component is 0? The x. X is 0, and we need to look for y. So let's substitute for x with 0. So y equals 0 squared. That means y equals 0. So, well, I should complete this. So 0, comma 0. And here, once again, 0, comma 0. So the x and y intercepts are the same. They are the origin. Right there. Right? Any line going through the origin, it's going to intersect both x and y axes. And you can quickly, this is a very familiar curve. This is a very famous function, and it is a familiar curve. But if you're not familiar with it, one way to graph it is, because you can't, this is not a linear line. This is not a straight line. So to graph it, you're going to need more than the intercepts. So let's say x and y, right? This is in case just you want to see, well, okay, this is a famous function and everybody knows what the graph of it looks like, but what about if it was a strange function and nobody knew what the graph looked like? What do you do then? Well, you can simply pick some easy, not difficult, because you want to get a rough idea of where this line is or this curve is. You pick some easy x values and you calculate the y values based on the function, and you find and you try to connect those points with a smooth curve. So let's do that, because that's a useful exercise too. So I'm going to pick some easy x values. I'm going to pick -2, -1, 0, 1, and 2. Right? So I'm going to plug in here -2 squared, +4. -1 squared, 1. 0 squared, 0, which is what we have here. 1 squared, 1, 2 squared, 4. Right? So these are our points. So let's plot these. Right? These are the x and y. We found 5 points in it, 5 points, one of which is 0, 0, right? That one. So let's plot the other 4. -2, comma 4, -2, comma 4, that's that point. That's -2, comma 4. -1, comma 1, that's that point. -1, comma 1, that point. 0, comma 0, right there. 1, comma 1, that point. 1, comma 1. 2, comma 4, 2, comma 4. Okay, now that we have more than just intercepts, we can plot this curve. So it's going to go like this, like that, like that, like that. Okay, but this one was an easy curve because everybody knows the graph of y equals x squared. It looks like that. Okay. Here's another line we need to graph. This is not a straight line, because look at the power of x, right? This is a quadratic equation. It's going to look like a curve like that, but the graph is going to look something like this, but it's not going to go through the origin like that. This is not going to go through that. So let's find the x and y intercepts but we're going to need more than that, right, to plot this. But anyway, let's find the x-intercept. Oops. Which component is 0 for x-intercept? The y component, right? And the x-intercept, the x value we're going to need to find. So let's plot for y with 0 and solve for x. This is a prime quadratic equation. A prime quadratic equation is a quadratic equation that cannot be factored. if it cannot be factored, how can we find the solutions of it? How can we find the x values? Well, we're going to apply the quadratic formula. Remember the quadratic formula? You need to remember that and memorize it for this course, okay? So the quadratic formula is equal to x equals minus b plus or minus square root of b squared minus 4ac over 2a. Now, in our case, in this case, the a is the coefficient of the quadratic term, which is x squared. So a in our case is 1. B is the coefficient of the x term, that is 2. C is this whole thing. C is the constant, right? -1. So let's plug in this formula with these values and see what are the different x-intercepts. So we have x equals minus b is minus 2 plus or minus b squared is 2 squared minus 4 times a times c, which is -1. All of that over 2a. 2a is 2 times 1. Right? I just plugged into this formula with these values. So we have x equals minus 2 plus or minus 4. 2 squared is 4 minus 4 times 4 minus 4 times minus 1, that's positive 4. So 4 plus 4, not minus 4, because this minus will make this minus positive. So 4 plus 4 is square root of 8 over 2 in the denominator, right? So then what do we get? We get x equals the square root of 8 minus 2 plus or minus. We can simplify this, right? We can simplify this. How? Plus or minus square root of 4 times 2 divided by 2, right? I can write 8 as 4 times 2. There's nothing wrong with that. But then 4 is 2 squared. Any part of 8 that can be written as something squared is useful. Why? Because you can remove that part from inside the radical expression. So now I broke the 8 up into 2 pieces, one of which you know and I know, 4, which can be written as a perfect square. What is a perfect square? It's 2 squared, right? 4 is 2 squared. So let's write it. X equals minus 2 plus or minus square root of 2 squared times 2 divided by 2. Why did I do that? Well, because now I have something underneath this square root that is being written as a squared, perfect squared form. That means I can remove that piece from the radical. What I will be left with is just this 2. And when this term comes out, the 2 gets canceled. So this is what we have. X equals minus 2 plus or minus, remove this 2 squared, bring it out, 2. In the process, it loses the power because that 2 is equal to the index. This number we put here in the radical expression is called the index. It's missing. It's blank. What does it mean? It means that it must be 2. By mathematical convention, if this index is blank or missing the number, that means it's 2. So 2 divided by 2 is 1. So there we have, the power is 1. And this 2 is gone. What we have is another 2 on the inside over 2. Right? Okay. So now we can factor out the 2 and simplify this even more. X equals, I guess we can say 2, factor out 2 times minus 1 plus or minus square root of 2 over 2. Okay, I just factored out 2. Factoring is the opposite of the distributive property. So how do you know if this factorization is correct? It's very easy. Just distribute this 2 back into what you have in the numerator. If this factorization is correct, then you must get this expression back. Do you? If you multiply this, if you distribute this 2 into these 2 terms, do you get this back? 2 times -1, -2. 2 times plus or minus square root of 2, plus or minus 2 square root of 2, right? This 2 times that. You do get, if you distribute this into this, you're going to get what you had before, which is how you can quickly check if you've been able to factor the expression properly. Okay? So now, notice everything is in the form of multiplication, right? If this was, let me write this down because this is very important. If this expression was like this, x equals 2 plus -1 plus or minus square root of 2 over 2. Could I simplify these? Could I say 2 and 2 cancel out? No. I've seen this happen many, many times, guys. We cannot simplify this 2 by this 2 because there is a plus here. Okay? Then why can we simplify here? Because it's being multiplied. We do not have a plus there. Instead, let me grab my thicker marker. We have a multiplication here. So instead of 2 plus, we have x equals 2 times -1 plus or minus square root of 2 over 2. There is a multiplication there. When you are multiplying or dividing, then you can cancel because it's being multiplied by that, not added. Okay? So here, yes, being multiplied, 2 is being multiplied by all of that. Hence, it's called a factor. So then x is equal to -1 plus or minus square root of 2. Okay? So this square root of 2, if you use your calculator, do I have my calculator here? Yes, I do. See, square root of 2 is an irrational number. If you calculate it, because these are our x-intercepts, right? So we want to have a rough idea where these 2 x values are. Square root of 2, let's calculate square root of 2. It's going to be 1.41. It's irrational, so those numbers never end. For our purpose here, because we're manually graphing this, we can say 1.4. We can round it to 1.4, right? So let's do that. We're going to say x equals -1 plus or minus 1.4 instead of that. Therefore, -1 plus 1.4. What do we get? We get 0.4, positive 0.4, right? That's -1 plus 1.4, we get positive 0.4. How about -1 minus 1.4? We get another x value, which is -2.4. So what are the x-intercepts? The x-intercepts are as follows: 0.4, 0, and -2.4, 0. Okay, again, these are estimates because I rounded the square root of 2 to 1.4. Okay, so these are roughly where these points are. So what about the y-intercept? Well, the y-intercept is much easier to find. If you don't mind, let me put it here. I'm going to put it here because I'm running out of space here. I'm going to write the y-intercept here. Y-intercept it means which component is 0? The x. X is 0 and we need to calculate the y, right? So in our equation here, let's substitute for x with 0 and find what y is. Y equals 0 squared plus 2 2 times 0 minus 1, right? So we get y equals minus 1. So the y-intercept is 0 equals negative 1. So this is our y-intercept. These are our x-intercepts, right? Can we graph this? Absolutely. Let's do it. So 0 comma negative 1 is that one. That's the y-intercept. 0.4 comma 0 is somewhere between 0 and 1. So I'm going to put a dot right there. Minus 2.4 comma 0 is somewhere between negative 2 and negative 3. So let me put a dot right there. Okay. Let's see. Did I... So 0.4 comma 0, negative 1. I think that's correct. I'm just double checking what I have here. 2 times 1. Just double checking these numbers to make sure that my numbers are correct. 2 factored out. Minus 1 plus 1.4, like that. Yeah, it looks okay. So, but let's do on this one just to make sure. Let me draw the graph here, and then we will graph this on the computer as well. Okay, so this, given these three, because what we don't have here, guys, is the vertex here. We know the graph is going to go like this because it says x squared. That's a quadratic equation. So the graph is going to be like that, just like this one. The graph is going to look like this, but we don't, for this one, we don't know where the vertex is because, and I don't want to calculate it because in this class, we are not that far yet, so I don't want to jump to content we haven't yet covered. So I'm going to roughly sketch this. Then I'm going to go to the computer so we see a more exact graph of this equation. Okay, so roughly what we have is that. Okay, like that. To go through all these 3 points. But this point, we don't know. We can calculate it, but like I say, I don't want to talk about it because this section isn't yet talking about that topic. So I'm just going to leave it as that, as a basic graph, or roughly a sketched graph. At this point, the important things about this example are these. First, please make sure you remember the quadratic formula, this one. This quadratic formula, please make sure that you remember that for the rest of the semester, that one. We're going to be using this again and again. Also remember how we found the intercepts, what x and y intercepts are. Y-intercepts are any coordinates for which the x value is 0. X-intercept is any coordinate for which the y value is equal to 0, and that. So those are the important things. So as I switch from dock camera to computer, you're going to see a glitch on your screen. So just ignore it. That's going to be just a fraction of a second. When that switch happens, your screen is going to blank out, but everything is going to be there. Okay, your screen should be up now. Here is Desmo's calculator website. You can access it anytime on your own computer. And I want to graph that equation so we can get a precise look at what it looks like. Y equals x squared and plus 2x and minus 1. Right there. Okay? So now we know where that vertex is. See, as I put my cursor on it, on that word vertex, the coordinates pop up, right? You should be able to see it on your screen too. It's -1 comma -2. Let me snap to it. So -1 comma -2, right there, the blue dot, that's the, and let me label it with the coordinates, -1 comma -2. So yeah, our graph was roughly correct, right? But this is a computer and that is manually drawn. So there you have it. Okay, great. So now that we know that, let's go back to the dock camera. Again, when I go back to the dock camera, your screen is gonna blank out for a second, but ignore it, we'll be back. Okay, there we are again. All right, continuing with this discussion, the other formula we should know, in addition to the quadratic formula that I mentioned, is the distance formula. So the straight distance between 2 points, this is not talking about the curvilinear the distance, right? Like a roadway. Like how long is from here to, let's say, state line. That's not a straight line, right? It's a curved road from here to state line. So we're not talking about that kind of distance. This is a straight line with no curves in the distance or in the path. The straight distance between 2 points that have coordinates x1, comma y1 and x2, comma y2 is partially covered there. That is x2, comma y2. The straight distance between any 2 points like that, as I've shown on the graph here, can be calculated using this distance formula. So straight distance between 2 points, you take the difference between the x components of the 2 points and you square that difference. Then you add that to the difference between the y components squared. Okay, so please make sure that you remember this distance formula. The other formula we need to remember is the midpoint formula. The midpoint formula is if you have the components of, if you have a straight line and you have 2 points and you want to know the coordinates of the middle point between those 2 points, you use this formula to calculate it. So you add, not subtract, add the x components of the 2 end points divided by 2, comma, you add the y components of the 2 end points and divided by 2. Okay, so knowing that, let's find the distance between each pair of points. If necessary, round your answer to 3 decimal places, if necessary. Okay, so this is the distance formula we're using, right? So let me write it here. The distance formula, I'll use the lowercase d, is equal to the difference between x1 minus x2 squared plus y1 minus y2 squared. So we take the difference, square it, and then add them together. For the sake of convenience, let's label these. So x1 comma y1, x2 comma y2. We could do that, right? So let's plug in. And I want to strongly encourage you to please, for this part A and B, pause the video, apply the distance formula on your own, and then compare your solution with mine. Again, that's a winning strategy if you're doing that. If you're just watching me working out these problems, that's not going to be very helpful to you. Okay? So let's plug in for these values. We have the distance formula, x1 minus x2. x1 is minus 3, minus x2, which is 2. Square that difference, plus y1, which is 7, minus y2, which is 11 squared, right? D equals minus 3 minus 2, that's minus 5 squared, plus 7 minus 11, minus 4 squared. Minus 5 squared is 25. Minus 4 squared is positive 16. And we have square root of 6 plus 5 is 11, square root of 41. Okay. Okay, so we can leave it like that. And it says round your answer to 3 decimal places, but this is a more exact answer. So let's keep the answer like that. Okay. Okay, so this one, once again, this is, let's label these x1 comma y1, x2 comma y2, and this is our formula, right? That's our formula right there, the distance formula between 2 points on a straight line. So let's plug in. So we have square root of x1 minus 60 minus x2, which is minus 20 squared, plus y1 5 minus y2, which is 35 squared, right? I hope our solutions agree. So D equals minus 20, that's positive 20. Minus 6 plus 20, that's minus 40 squared, right? So we have minus 40 squared plus 5 minus 35 is minus 30 squared. Okay. Minus 40 squared is positive 1600. Minus 30 squared, that's positive 900, right? So we have D equals 2500. Okay, let's see. That'll be probably 50, right? Let's see. Let's just verify that. So a square root of 2500. Let's see if we get 50. We should. 50. Okay, so we just verified it. D equals 50. Oops. So that's how we apply the distance formula in 2 cases. Okay, so now we have gotten to the circle. The point 01 is on a circle that has center at this. Find the length of the diameter of the circle. So we've learned about the distance between 2 points on a straight line. Now we're being asked to apply that concept to a circle. Okay, let's get an idea with what this is talking about, right? So I'm going to draw a quick graph just to give us an idea, a pictorial idea of what we're doing here. Okay, these are easy numbers, 0, 1, and negative 3n comma 5. So let me 1, 2, 3, 4, 5, and 1, 2, 3. Okay, 1, 2, 3, 4, 5. Negative 1, negative 2, negative 3, and that's 1. Okay, the point 0, 1 is on a circle that has center at negative 3, comma 5. So the center of this circle is at that location. Negative 3, comma 5 is somewhere here. Okay, and we're told that point 0, 1, where is that? 0, 1 is that point. So that is 0, comma 1, and that point is negative 3, comma 5 is there. So this is the center of a circle. I don't know if I'll do a very good job of drawing this circle, but I'll try. So if we do this like that, so that point 0, 1 is on a circle of center negative 3, comma 5 right there. Okay, so it says find the length of the diameter of the circle. Well, we have a formula that can help us find the distance between those 2 points, right? That one, right, that. Let's call that D. Well, let's call that R for radius. Okay, so R is the radius of this circle. Okay, we have a formula, the distance formula, that can help us find that distance, that straight line distance between the center and point 0, comma 1. Once we have that, we can double it to get the diameter, because they want the diameter, not the radius, right? Find the diameter. So we can double that distance to get the diameter. So let's do that. So applying the distance formula with, let's call 0, comma 1 as x1, comma y1, negative 3, comma 5 as x2, comma y2, right? Okay, so x1 minus x2, which is 0 minus minus 3 squared, plus, I'm just applying the formula, right? The formula was, let me write it here, the distance is square root of x1 minus x2 squared plus y1 minus y2 squared. We're applying that to these 2 points. As you can see in graph, it makes sense, right? We know the radius, we can double it to get the diameter. Okay, the diameter would be, the diameter of the circle is this whole thing. That. So let's find R and then double it. And that's what we're doing. y1 minus y2 squared. So y1 is 1 minus y2 is 5 squared. So minus minus 3 is positive 3. Positive 3 squared plus 1 minus 5 is minus 4 squared, right? Minus 4 squared. What do we get? We get 3 squared is 9, plus minus 4 squared is 16. D is equal to square root of 25, or I should not, well, D is really R in this case, right? Let me add that. Radius equals D, radius equals D, radius equals D. So that radius is equal to 5. If radius is equal to 5, then the diameter is equal to 2 times R, right? So it is equal to 2 times 5 or 10. There. Okay. So we use the distance formula in conjunction with the information we were given to answer this question. And this was just elementary geometry that we learned in middle school, right? Basic geometry. The diameter is in a circle is twice the radius. Okay, so now in the next example, we're being asked to find the midpoint. We talked about the midpoint, right? This is how we calculate the midpoint. This is the formula. We add the x components for 2 points, divide by 2, comma, add the y components, divide by 2. So there's no subtraction here. Subtraction is in the distance formula. Subtract the x components squared, add to the difference between the y components squared, and take the square root of that. That was distance formula. So let's label these. You don't have to, but just for as a help. And let me write down that the midpoint formula here is equal to x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Right? So let's plug in. x1 is 7 plus x2, 9, divided by 2, right? I'm plugging in here. Comma, y1 is minus 2 plus y2, which is 5, divided by 2. So equals 7 plus 9 is 16 divided by 2. Negative 2 plus 5, 3 divided by 2. So we have 16 divided by 2, 8, comma, 3 halves. You can either leave it like this, or you can convert that to decimal because it's an easy decimal, right? 8, comma, 1.5. Okay. Now this one, the midpoints, the same formula, right? Let me box this so it stands out as our formula, like that. Let's apply it again here. Please, if you haven't done so already, please pause the video, find the answer to this, and then come back to the to see my solution. Okay, so these are x1 comma y1, x2 comma y2, and we're going to plug into that formula. So we have x1, which is 1, plus x2, which is minus 1, divided by 2, comma, y1, which is minus 2, plus, I'm plugging into this formula, plus y2, which is 2 over 2. So what do we get? 1 plus negative 1, 0 over 2, minus 2 plus 2, 0 over 2. What do we get? We get 0, comma, 0. So the origin is basically the midpoint between these two lines, or 2 points. These 2 points, the midpoint of the straight line that connects these 2 points has coordinate 0, comma, 0. Here, the midpoint of the straight line that connects these 2 points has coordinates this. Okay. Next problem, it says the points, these 2 points are endpoints of a diagonal of a square. Let's draw this. It's always nice to draw a picture when we can. It helps us better understand what's going on or what we're doing. So suppose that's a square, right? And we're told that the points this and that are endpoints of the diagonal of a square. So if that is a diagonal and that is a diagonal, right? Suppose this is 1 comma square root of 2, and this is negative 3 comma square root of 5. Okay, and let's draw the diagonal here. right there. Okay. Determine the coordinates of the center of the square. We do know about this, just like before, we know from elementary geometry that if you have a square and you draw the diagonal, the midpoint of the diagonal from corner to corner of a square, or any rectangle for that matter, the middle point of the diagonal is the center of the square or the rectangle. This we know from elementary geometry. So let's apply the midpoint formula to find that. And just so that we can look at it as we apply it, I'm going to write down the formula once more. So x1 plus x2 over 2 and y1 plus y2 over 2 are the coordinates. So let's label these. We don't have to, but I guess it makes it easier to look back and forth between these numbers. Okay, so x1 plus x2 divided by 2. x1 is minus 3 plus x2 is 1 divided by 2, comma, y1 plus y2 divided by 2. y1 is square root of 5 plus y2 is square root of 2 divided by 2. Right? So what do we get? Negative 3 plus 1 is negative 2. Negative 2 divided by 2, right? Let me do it in the steps. Negative 2 divided by 2, comma. We cannot combine these guys. If this was square root of 2 plus square root of 2, then I would say, let me bring my scratch paper here. I need to explain this. If we had, and this is my scratch paper, so if we had square root of 5 plus square root of 5, you could write 2 square root of 5. Okay? If we had square root of 5 plus 2 square root of 5, you could say 3 square root of 5, because 1 plus 2 is 3. If we had square root of 5 minus 3 square root of 5, you could write minus 2 square root of 5. Okay? By the same token, if you had square root of 2 plus 5 square root of 2, you could write 6 square root of 2. If you had minus 3 square root of 2 plus 7 square root of 2, you could write 7 minus 3, because square root of 2's are the same. So 7 minus 3, positive 4 square root of 2. If you had 8 square root of 2 minus 3 square root of 2, you could write 5 square root of 2. Do you see what's happening? If square root of 2, if you add or subtract those, you could add or subtract the coefficients with the square root of 2 attached. Just like that. These are all allowed. But we cannot do that with this. I cannot say square root of 5 plus square root of 2 is square root of 7. No. Okay? No, this is not allowed. So what can we do here? Nothing. We should just write it down as it is. Don't simplify it. If it cannot be simplified, do not simplify it. So we're going to write this as it is. Square root of 5 plus square root of 2 over 2. Now, can we simplify this? Absolutely. So we have parenthesis negative 1 comma square root of 5 plus square root of 2 over 2. And we're done. Okay? Can you calculate this number? Yes, but you'd have to, that number would not be exact. Suppose this was a homework assignment. Suppose this was one of those problems you see in my lab or my math lab for your homework. They would want you to give the exact response. That is an exact response, answer. If you convert it to decimal, because square root of 2 is irrational, you won't get an exact answer. You'll get an approximate one, and I don't think the computer-based programs would accept it from you. So computerized assignments, exams usually want you to enter the answer like that, as a whole, not converted to decimal. Okay? So this is just, you would leave the answer like that. Okay. We reach the equation of a circle. Okay? For those of you who will be taking Math 127, which is trigonometry, you'll delve much deeper into this subject than here. But here, we just basically introduce it. And it's a good knowledge to have for your future math courses that you might be taking. Okay, so the equation of a circle, usually, in most books that I've seen, when they want to give you the general equation of a circle, as you can see it here. Let me bring this down a little bit. The way they label the terms, they usually label the center as H comma K. Usually they use those letters, H comma K. If you don't, as long as you understand how this graph relates to this equation or formula, as long as you can visually connect this graph or circle to this equation, that's what I expect you to be able to do. So don't look at this in isolation or separate than that. Connect this drawing to this equation in your mind and visually. That's what you need to do. And what I'm saying is that in most books that I've seen, they label the center of the circle coordinates as H comma K. Those are the letters for some reason they use. And then in the equation you have H and K, those coordinates of the center of the circle showing up in the formula as H and K. So in this formula, H and K are the coordinates of the center of the circle, and R is the radius, and R squared, of course, is just radius squared. Okay? So not only you should remember this, memorize this formula, but also what I'm asking you to do is connect this graph with this. How are these two entities? This symbolic form is related to this geometric form. Make that connection. That's what I need you guys to do. Okay? Okay, so knowing that, basically what this is saying, it's saying that if you, x and y, by the way, x and y are any points on the circle. That's x and y. Any point on the circle is xy. xy means any point on the circle. H and K are the center of the circle, the coordinates of the center of the circle, and R is the radius. Okay, and this is H comma K. So, now let's go over this example. It says find the equation of a circle that satisfies the given conditions. So we need to find, this is a general equation of a circle, right? That's for any circle. Now we need to find a specific example of the equation of a circle. So it says center of the circle must be at 6 comma negative 5, and circle passes through this point. So this point is on the circle, and this is the center of the circle, right? So why do we need both? We could plug in x minus h minus 6 minus 5 and give the equation, but we would only be able to, with this set of coordinates, we would be able to write down the left side of this equation. What about the right side? Right? We need to know the right side. We need to know the radius. So the radius, this point is on the circle. This is the center of the circle, right? Let me draw a quick picture here. I hope I can draw it as best as I can. So let's get a geometric feel for this problem. We don't have to draw the drawing. It's just for the sake of clarity, that's all. So these are easy numbers, so I'm going to increment 1, 2, 3, 4, 5, 6, 7, and then -5, 1, 2, 3, 4, 5. Let me move this up a little bit, like that. And then 1, 2, 3, 4, 5, 6. -5. Okay, so they're telling us that the center of this circle is at this point, 6, -5. 6, -5 is that point. There. And then 1, 7, 1, 7 is right there. That's a point on the circle. For sure, I'm not going to be able to draw this circle because it's going to go off the page. It's a big circle. Okay? I mean, if I did draw it, it'll be like that. It'll go off the page. But they tell us to write the equation of this circle. And this is r. So we need the r value. We need the radius. So my graph is definitely not correct, right? But this is what they want us. This much. I wanted to draw this much to show what they're asking us to do. This is the coordinates of the center. The 1, 7 is a point on it. The circle passes through 1, 7. So that's a point on the circle. So with that, we can use the distance formula to find the r, and then we can square that quantity to get r squared. To get r squared, which is what we need for the equation of our circle. So let's do that. Okay, r is equal to square root of 6 minus 1 squared plus -5 minus 7 squared. I just applied the distance formula to find r. The distance formula to these 2 points to find the straight line distance between those 2 points. Okay, r is equal to 6 minus 1 squared is 5 squared plus -5 minus 7 minus 12 squared. What do we get? We get 25. 5 squared is 25 minus 12 squared. This power is even, so it'll cancel this minus. If it's 4, 6, 8, 10, 12, any even power would cancel the negative, make it positive. So 12 squared is a famous number. It's 144, right? So plus 144. So r is equal to a square root of 169. Is that 13? I don't remember. Let's see. Let's see if square root of 69. So square root of 169, 13, right? So r is equal to 13, but r squared means 169 again, right? R squared is 169. So that's what we want. That's what we want in the equation of the circle. So let's write down the equation of the circle. You can see it up here in general form, right? So the equation of the circle is x minus h. This is h comma k, right? This or that, right? That point, which is here, is h comma k. So, and I'm applying this equation to it. So x minus h would be x minus 6 squared. Look at the, as I ask you, there's a connection between this formula and this geometry of a circle. So compare x minus h is x minus 6 squared. X minus h squared becomes, in our case, becomes x minus 6 squared plus y minus k squared, right? Y minus k is minus 5. So minus 5 squared equals r squared, which is 169. So did you follow what happened? If not, please pause the video, go back, rewind the video to a minute ago and make sure that you followed what's going on. We have the general equation of a circle here, and I'm plugging into it with the information we have. So we should simplify this. We get x minus 6 squared plus y minus 5 is y plus 5 squared equals 169. So this is the equation of the circle. Given the data we had, given the information we had to begin with. Okay, like that. So once again, they want us to find the equation of a circle such that the center is here and the diameter, and the circle has a diameter of length that much. Well, the diameter is 2 times, let's call this diameter d, right? Not distance, this is not the distance. Diameter is, let's call it with capital letter D, because I've been using lowercase d for distance. So d. So d is equal to 2 times r, right? R is the radius, right? Diameter is equal to 2 times the radius, right? We know that from elementary geometry. So let's plug in for the diameter with 8.2. So 8.2 is equal to 2 times r. So r, we're solving for r, so we need to isolate r. How do we isolate r? We get rid of the 2. Divide both sides by 2, we get r equals 4.1. Right? That's the radius. We can test, I mean, I'm pretty sure that's correct, but let's double check. 8.2 divided by 2, 4.1, right? That's the radius. We know the center. We know that the general equation of a circle is this, right? Equation of a circle is equal to x minus h squared plus y minus k squared equals r squared, right? We know that. Now, in our case, we're looking for r. We had the diameter. We didn't have r. We had the diameter. We now have it. So r squared, what is that? R squared, let me bring this back. 4.1 squared, right? Let's raise that to second. It's 16.81, right? Let's do it again. 4.1 squared is 16.81. That's the r squared side of this equation. It's going to be 16.81. Okay, therefore, r squared is 16.81 using the calculator. So where is our h comma k? This is our h comma k. H comma k is 4 comma 5. So we have the r squared, which we need. We have the h comma k, which we need. Let's write down the equation of this circle. We have x minus h, which is 4 squared. I'm plugging into this equation, right? Plus y minus k, which is 5 squared, equals 16.81. There. Okay. I hope things are beginning to make sense. All right. Number 10, it says in each of the following cases, find the center and radius of the circle and then graph the circle. Well, compare this with the general equation of a circle, right? Which is x minus h squared plus y minus k squared equals r squared. Please pause the video, think about and solve this question on your own before coming back to the video. Please do that. Think about it. Write down your best solution, but don't watch the video without giving it your own thought. Okay? Your thoughts are far more important than my thoughts and my solutions. The reason is because you're developing those thoughts. My thoughts and my solutions are useless to you because if you just memorize these, they are useless to you because those are my thoughts, my solutions. You need to develop your thoughts and your solutions. So please pause the video, resist the temptation to look at my solution without doing your own work. Resist that temptation. And then once you have your solution down, your thoughts, your valuable thoughts, then unpause the video and see what I've done. And if we agree, perfect. If we don't agree, then you know how to correct your thoughts, which is the true purpose of learning, how to correct how you're thinking about these things. Okay, not memorizing my solutions. Okay, so I'm assuming you've done that, and now you're back. So compare this general equation of a circle with the specific equation that we are given. Okay, let me write this down because it's important for you to know this. This is a specific equation. This is a specific circle. And this is a general. This is any circle. Any circle, a specific circle. So they're asking us to compare what the question is implying to compare this specific case they're giving us with the general case and find where the center is and what the radius is, the length of the radius is. Okay? And then they say graph the circle too. Okay. So comparing this any circle equation with this specific case, what would h and k have to have been? Do they appear anywhere? No. So h and k must have been 0. So h must have been 0. K must have been 0, right? X minus 0 squared is x squared. Y minus 0 squared is y squared. Okay? And r must have been equal to 9. Right? R squared is 81. So r equals 9. Right? R squared equals 81. Therefore, r equals 9. And h and k are zeros. So, where is, if h comma k h comma k is equal to 0 comma 0. If the center of this circle is at the origin, then that's the origin right there. That's the center of this circle. And the radius is 9. And 9 is here, here, and here, and here. So we need, when I draw the circle, Let's see if I can do this right. Like that. That's as best as I can. 0, 0, and that is 0, 9, and that will be 9, 0. That's negative 9, 0. Those are those nodes or those points. And 0, negative 9. Okay, like that. What else to find the center? The center, well, let me box these because they ask us to. So h, k is equal to 0, 0. That's the center. Then they say the radius, r is 9, right there. And the circle as we graphed it. Okay? So you can see in the examples we've done, constantly they're asking us to establish a connection between this general case or any circle equation with the graph of it. So that's very important, how they are related. Where is the center, where is the radius, and then draw it. Okay? So in this case, again, for part B and C right underneath it, please pause the video, download the blank worksheet for this section which I posted on Canvas, write on a piece, you don't have to print it, just write down on a scratch paper the solution to both part B and C before you see my solutions. Okay? I'm assuming you've done that, and now you're here to see if our solutions agree, which is wonderful. So the first thing I'm going to do is write down, this is again a specific circle. Let me write down the equation of any circle. Right? So this is any circle. Specific circle, which we've been given, that's any circle, right? General, any general circle. So compare this with that. What would h have to have been? Compare this with that. What would h have to have been? H must have been -2. Because minus 2 will give you the positive 2 you see here. What about k? What would k have to have been? Compare this with that. K must have been 0. Right? So based on that, then h comma k is equal to -2 comma 0. Okay. What about the radius? We know that r squared is 100, right? That's the other side. Compare that. So that means r is equal to square root of 100, or r is equal to 10. That's the radius. Okay? So the center, this is the center. Center of circle, sorry. Center of circle. And this is the radius. Okay. So the center is at -2 comma 0. -2 would be here and 0. -2 comma 0 is right here. Okay, that's the center. Where is the radius? It has length 10. So go up 10, go this way 10 units. That would be -12. Right there. Go down 10. That would be here, right underneath -2. And go this way 10. So that's 2 and then another 8. So right there.
Okay, so let me label these points. This is positive 8 comma 0, and this is negative 12 comma 0, right? I'm just, because radius is 10, I'm just taking 10 units on each side of the where the radius is, and I get these values that way. So 10 plus negative 2 is positive 8, right? And this is negative 2 comma 0. Negative 2 comma 0. That's the center of that circle. And then this is 0 comma negative 10. Oh, sorry, negative 2 comma negative 10. That's that point, negative 2 comma negative 10. And that is negative 2 comma positive 10. Okay. All right, so let me try to connect these points with a smooth curve as much as I can. Like that. Okay, the bottom doesn't look very good, I know. But that's how it works. Okay. Okay, next. Again, we have been given a specific circle. That's a specific circle. Let's compare this with the equation for any circle. Okay. Any circle, right? Like that. Okay, so compare. What would h have to have been? Comparing this with that, h must have been negative 4, right? Because minus 4 will give us the positive 4 that we have here. What would k have to have been? K would have to have been minus 5, right? Because minus 5 will give us the positive 5 we have here. So h comma k, or the center of the radius, has coordinates negative 4 comma negative 5. Okay, that's the center of circle. Okay, how about the radius? The r squared is equal to 9. So r is equal to square root of 9. R is equal to 3. See, by square root property, we must give plus or minus 9, right? And even here, we get plus or minus 100 by square root property. But I wrote positive 10, not negative 10. Do you know why? Because distance is always positive. Distance is always positive. So that's why we use the positive 10 and discard the negative 10. Okay, but this would have been plus or minus 10. Normally, it would have been plus or minus 10 if this was the square root for an x. If x squared was equal 100, I mean, let me use a scratch paper here to make this point. This is important. So if you have x squared equals 100, then x equals plus or minus square root of 100, right? This is very important for you guys to remember. Plus or minus. Okay, so x would be plus or minus 10. But this x does not represent a distance. It's just any x value in a function. So you could accept both answers. But if the value you're calculating is representing a distance of the radius, which is a radius of a circle, then you can't accept the negative piece. So you discard the negative piece, you accept the positive one. Because in this case, this is not just any x value. This value represents the radius of a circle. That's why we went and I just boxed the positive 10, not negative 10. I didn't even consider it. Okay? Same way here. If you just calculate x squared equals 9, so if you have x squared equals 9, so x equals, if you take the square root of both sides, you end up with plus or minus square root of 9, x equals plus or minus 3. But that's just any x as part of a function. That's how you would give your answer. If you say x equals 3, you will be marked off. Your answer is not correct if you say x equals 3. But here, this r represents the radius of a circle. It's a distance. The value you're calculating represents a distance. So we discard the negative. Let me write that down. Discard r equals negative 3 because r represents a distance, and distance is always positive. Very important for you to remember, because if you forget this, not now, but later, where we need both plus and minus values, it's going to create problem for you. You're going to be marked off, and you're going to wonder what happened. You might think, well, earlier he was calculating the radius. He just said r squared equals 9, r equals 3. So why am I being marked off now when I have an x squared equals 9 and I write down x equals 3? You'd be scratching your head thinking, what's going on? Well, now is the time to remember that here, r represents a distance. So you need to discard the negative piece and accept only the positive value. Later, when we have x squared that we're calculating in other functions where x is not a distance, you need to give both plus and minus values. Okay? Please remember that. Okay, so radius is equal to 3, and that's where the center is. So let's plot these points. The center is negative 4 and negative 5, right there. This is the negative 4 is right there, and negative 4 along the x, negative 5 along the y, right? Right there. That's the center. Then with radius 3. So radius 3 on either side of this would be, if this is negative 5, so go up until negative 2 right there. Good. This is a smaller circle than the other ones, right? The bigger the circle, the poorer my skills of drawing it. So this is a small circle. That's good. So then another 3 units on this side. So if this is negative 4 comma negative 5, which is that, so 3 units on this side, it would be negative 7. So negative 4, negative 5, negative 3, negative 6, negative 7, right there. 3 units on this side, so it will be negative 1. And 3 units down, so it will be negative 8, right? Because this is negative 5, so negative 8 would be right here. Okay, so this is a small circle. It's a little bit easier to draw. So let me label these points just to make sure that you can track what I've done here. So radius is 3, right? So that radius r is equal to 3. So that point is 3 units higher than this. So that'll be -2, -4, comma, -2. That point. That point is, it would be -1, comma, -5, right? And then this, the center is -4, -5, and this point is -4, comma, -8, right? 3 units below the center. And that point is negative, so the x value would be -7, comma, -5. Okay, I just plotted those so to make sure that the radius that I'm drawing is equal to 3. But as long as you identify the radius and then draw a rough sketch, you should be okay there too. Okay. So with that, we have wrapped up section 1.1. Thank you very much for persisting through this video. As I said, for the rest of this course, please make sure that you read the book before you watch the video or attend class. And please, please make sure that you pause the video before you see my solutions. Then, once you have given yourself the opportunity to write down your own thinking, the production of your own mind, then look at my solution after that. Okay? Have a nice day for now, and until next time, see you all again.